Hey everybody, in this video we are solving a quadratic inequality quite similar to the one we saw before. The one we saw before though gave us an answer, an interval between two constant numbers. This one is going to be two intervals connected with union, reaching out towards the infinities, right? So we'll just see sort of like a different answer going on in this situation. Anyhow, let's get started on this one. Here I have a quadratic. I know it's quadratic because the very easily identifiable 2x squared, anytime you have x squared, that's a quadratic expression. The graph that corresponds to that we refer to as a parabola. 2x squared plus 5x minus 12. If it was just 5x minus 12, that would be a linear inequality, but it's not. Is greater than or equal to the value of 0. Oops. Now, 0 is the x-axis. Y equals 0 is the x-axis. And then y equals 2x squared. Y equals 2x squared plus 5x minus 12. That is the quadratic slash parabola. So y equals, I'm just going to look at it as 2x squared. I want you to have a visual plus 5x minus 12. And y equals 0, and we're looking at this as a system of equations, as if they can be graphed on the same plane. Okay, so here's just a little sketcheroo. It's not going to be anything super precise. This is just to give us a visual representation, okay? So y equals 0, right? Y equals 0, we said is the x-axis. Here's that line right there. 2x squared plus 5x minus 12. Now, where is that exactly? Maybe I don't know, but I do know because it's positive 2x squared, I know it has the shape where it's opening upward my parabola. Now, does it cross the x-axis twice? Maybe. Maybe it just touches the x-axis, bounces off, and goes off in its own direction like that. That's also possible. Or maybe it has this shape and it never ever crosses the x-axis. If this third case is the situation, then this quadratic, 2x squared plus 5x minus 12, is always greater than or equal to 0. If it was the second case where it just touches right at the vertex on the x-axis and goes, again, this quadratic, 2x squared plus 5x minus 12, will also always be greater than or equal to 0. And then in the more likely scenario, it's likely going to cross and it'll only be greater than 0 here and here, and we would have to identify what x values correspond to that part of the graph. So how do I find out? The 0 is fine, that's the x-axis. How do I find out exactly where my parabola is? Well, the way you find out is you factor, because when you take any quadratic and set it equal to 0, you find your x-intercepts. And if I get two x-intercepts and I know my parabola is opening upward, boom, that's really all you need for this sketch. No one's asking you how high it goes, how low it goes, none of that. All I want to know is when is this above or below the x-axis, also known as 0. So let's go ahead and factor this. When I factor this, 2 is prime. It's the only even prime number, so I know that this has to be 2x and x. I'm just going over how to be quite efficient with your factoring. Now, AC method is asking us to multiply the A and the C, so 2 and negative 12. And that gives me negative 24. I'm always doing the list in my head in order. I'm not skipping anything. I'm not trying to be a hero. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Even if you think you found your pair of factors, always go through and make yourself really exhaust all your options, because if the middle number was 10, we can make a 10 with 2 and 12 and with 4 and 6. It's all a matter of which ones are positive and negative. So it does matter. So it's always good to make sure. The pair of numbers I want to use to make 5 would be negative 3 and positive 8. Those, when I'm doing it factoring this quicker way, will be my outer and inner. Since I have to have 2x and x, right, my outer can't be the negative 3x. it has to be the positive 8x because 2 times what? Oops. 2 times what, works out nicely to be -3. That's not a nice thing for factoring. So I know I'm going to have a 4. That makes me 8x. And we said it was positive. So it's going to be a positive 4 since that 2x is definitely positive already. And then my inner will have to be the -3x. I already have x. So there is my -3. And the way we check to make sure we are actually right is double check first times first, 2x squared, check. Last times last, -12, check. And outer is 8x, inner -3x, and that makes positive 5x, and check. Now that it's factored, if you are the person who isn't paying attention at all, you would go ahead and again, remember, what are we trying to figure out? We're trying to figure out when this is greater than or equal to 0. But on the side, we have to find our x-intercepts. So I'm going to set these each equal to 0. Nowhere, no one has ever told you, no one ever told you to do that. Not a thing. No one's telling you to solve these as individual inequalities. Instead, I want to know when do I have x-intercepts? So 2x is 3 when x equals 3 over 2, which is 1.5. And then here when x equals -4. So here I'll mark a approximation, -4, and it's not to scale at all. Here, positive 3 over 2, which is 1.5. Again, those are my x-intercepts. Next, since my factors are each to the first power, individual first power corresponds with linear equations are first power. My graph of the quadratic that we have here, which is a parabola, will have at each x-intercept first degree behavior or linear behavior. That means it's going to slice straight through like a line. If I were zoomed in on only my x-intercept, I might mistake my graph for a line. So that's what linear local behavior will look like. And again, we have positive 2x squared. So I know my graph is opening upward and it's going to have pretty straight linear behavior at my x-intercept. So up on that end, straight through, up on that end, straight through. And of course it doesn't stay straight because that's just the impression it gives locally. My graph is going up in each direction. Now, is this a perfect parabolic shape over here? No, because I'm not graphing for accuracy. I'm graphing precision. I'm graphing just to know when it's above or below the x-axis. That is it. So again, this was -4 and this was positive 3 over 2. So if I want to describe when the parabola is greater than or equal to 0, I want to describe it by just using and referring to the parts here and here. These are the parts we want to refer to. This is when we are greater than or equal to 0. Here, my graph is less than 0. I don't want those parts. So again, the parts I care about are there and there. So now I want you to pretend, again, go on this imagination journey with me. We have a giant panini maker and we're going to squash this. And all I care about is where this flattens to on the x-axis. So I don't care about this part because that's not part of my answer set. So what is my final answer? Your final answer from left to right will read -infinity until -4 with a bracket because it says or equal to union 3 over 2 comma infinity. Boom. There you have it. So this works for all polynomials. Anyway, anyhow, whatever way you want to do it, that is how it'll work out. Hopefully you found this helpful. Takes a little practice. Go ahead and do a whole bunch of these yourself. Happy parabola face, right? Thumbs up, thumbs down, questions, comments, feedback. And let me know how you feel about it, okay? This is really critical to a lot of calc topics, so you want to be really good at it. All right? Check the playlist. Adios.